So let's continue now with section C, which is the option adjusted spread. And this takes a little bit of time to digest, so I would encourage you to memorize the points, major points that I underline over here. The option adjusted spread is the constant spread that when added to all the 1 year rates on the binomial interest rate tree will make the arbitrage free value. The arbitrage free value is the value produced by the binomial model equal to the market price. Okay, now let's just go a little bit deeper. In our illustration, if the market price is 102.218, okay, so now they are saying that if you look at this this callable bond, what the curriculum is telling us that this bond in the market is trading for, so the market price is how much? 102.21, so 0.218. I'll write it again, 102.218. This is the market price. What is the price that we calculated using the tree? Do you remember? So using the tree, the value we came up with was 102.899. Remember what I said when we were here? What did I say about the fact that if we are assuming a certain set of forward rates, I said that we are still taking a bit of a risk in that it is possible that interest rates are slightly different from this. So I said that it should not completely surprise you if the actual market price is a shade lower. Okay, so this, according to our calculation, was 102.899. So 102.899 was what we calculated. The actual market price is slightly lower. Okay, hopefully nobody is surprised. Okay, now the interpretation of option adjusted spread, that for now you can just, don't try to get too hung up with exactly where this is coming from, but just memorize it. So there is a difference between 102.899 and 102.218, a small difference. So one way of thinking about the option adjusted spread is that if we take all the interest rates, remember the interest rates from before, okay, and if we add, just for now imagine that this is magic, okay, 35 basis points to all the interest rates that we had before. So earlier, whatever rate we had, we add 35 basis points. So from our earlier tree, I'll just give you a small example so that you can relate to this. Oh, no. Okay, so if you look at what's the interest rate in this NHHH node, it's 9.1987. Okay, and if you look at the bottom one, it is 5.04. If you add 35 basis points to this, how much will you get approximately? Yeah, you should get, if you add 35 basis points, you will get 5.39. Okay, so that's what we've done here. In this tree, we've taken all the interest rates from before, added the same 35 basis points to all the interest rates, and by adding that same 35 basis points, what we get is the actual market price. So the interpretation of option adjusted spread is that equal amount that you add to all the interest rates in order to come up with the actual market price. Okay, so just take that statement as a given. Okay, now when you read this, it will make more sense. The option adjusted spread is the constant spread that when added to all the 1 year rates on the binomial interest rate tree will make the arbitrage free value, which is the value produced by the binomial model, equal to the market price. What was the market price? This number. In our illustration, if the market price is 102.218, the option adjusted spread would be the constant spread added to every rate in Exhibit 5. This was the earlier exhibit. That will make the arbitrage free value equal to the market price of 102.218. The solution in this case would be 35 basis points. This can be verified in Exhibit 11, which I just showed you, which shows that the value of this issue by adding 35 basis points to each rate. Okay, now, as you can imagine, you will not be asked to calculate that 35. Can you imagine how complicated it is to come up with that number? But conceptually, you might be tested, where an interpretation of the option adjusted spread is that equal amount that is being added to all the rates in the binomial tree in order to get the market price. The more important thing, however, is this point which keeps coming up. What the option adjusted spread seeks to do is remove from the nominal spread the amount that is due to the option risk. This measure is called option adjusted spread because, number one, it is a spread. It's a spread over what? Over some benchmark, such as maybe the treasury benchmark. So it's a spread. And second, it adjusts the cash flow to the option when computing the spread to the benchmark interest rates. Okay, so I think you can just memorize this. The core point is that when we look at option adjusted spread, that is the spread that compensates us for liquidity risk and compensates us for credit risk. The additional spread related to the option risk is what is removed when we come up with the option adjusted spread. Okay, so we've gone through all this. So this, I have a quick summary is, in our option free bond we had 104.6. When we used our binomial tree initially to get the callable bond, we got 102.899. The value of the call option was the difference, and callable bond in the market was 102.218. Then by adding 35 basis points to all the interest rates that we used over here, we got the market price, and this is another interpretation of the option adjusted spread. Okay, section D now. I think the probability of seeing this on the exam is very remote, and the learning objective also doesn't imply that you need to do this. It just implies that you need to do effective duration and effective convexity for bonds with options. So my advice on this is to just try to memorize this one slide. Okay, do these numbers make sense, or these formulas make sense, or do they ring a bell? What is duration? What does this V minus mean? Yeah, V minus is what happens to the value of the bond when the, so if we have a picture like this, if this is our, let's say that this is our bond with an option. Okay, so what is V minus? If the interest rate goes down, it's the new value. So that's V minus. What's V plus? When interest rate goes up, so this would be V plus. This is the value of the bond when the interest rate goes up. What's V naught? That was the middle or the current value. And what's the delta Y? Delta Y is that change, like it might be 10 basis points or whatever. And we always do this in decimals, if you remember. That's duration. This is the formula for convexity. I don't think you, as in strictly speaking, it was part of level 1, but very few people probably memorized this formula, and you are still here, so wasn't that necessary. Okay, so these are the formulas for effective duration and effective convexity. Okay, I'll just read this. I don't think we need to do problems on this. The problems that we need to do, we will do. Okay, so how do you come up with the effective duration and convexity of a bond that has embedded options? Given the market price of the issue, calculate OAS using the procedure described earlier. Okay, so right off the bat, I don't think an exam question will ask you to calculate OAS, but conceptually, that's step one. Step two, shift the on the run yield curve up by a small number of basis points. So you add delta y. Construct a binomial interest rate tree based on the new yield curve in step 2. To each of the 1-year rates in the binomial interest rate tree, add the option adjusted spread to obtain a adjusted tree. That is, the calculation of the effective duration and convexity assumes that the OAS will not change when the interest rate changes. Okay. Use the adjusted tree found in step 4 to determine the value of the bond, which is V1. Okay, so just read this once or twice, and then you use the same, this is V plus, use the same procedure to get V minus, and then come back here to come up with effective duration. And as you can see, if very low probability that you are made to do this. If you are made to do this, try to remember this. If you can't remember this, just mark B and move on. Okay, but it's not worth getting too hung up on this. Probability is just too low. Now we are going to value a puttable bond. Okay, how many people are excited about this? Okay, actually I just lied. We are not going to do this, but I'm going to ask you, just conceptually, we are not going to work through the mechanics. Okay, so conceptually, Ali, how would this procedure differ from what we did with a callable bond? Deducting the spread? Now, how would you do the valuation, Harun? Yeah. So the basic idea is, when does a callable bond get called? A callable bond gets called if the price that you show up on any node is more than 100. Now with a puttable bond, an investor has the option to put the bond back in the lap of the issuer. Okay, so when will you do that? When the price is high or when the price is low? So it's the exact same procedure. Notice that in the valuation of a puttable bond, when the price that you calculated as the present value is low, i.e. below par, or below the puttable price, then what number do you take? 100. So in the call option valuation, notice the bottom half of the tree, we were changing the high numbers into 100. With a put option in the upper half of the tree, where we have low numbers, we will change the low numbers to 100. So conceptually it is the same. Okay, so if you really want, you can go do this at home once. Actually do it just once, and you will confirm for yourself that the procedure is the same. Because you can't put it past the curriculum folks that on the exam they will give you a puttable bond. Okay, the concept is the same, so at least once in your life you should have practiced it. And I've seen exam questions where they are making you do this. Okay, which is why we have practiced this here. Does this look familiar? Will the puttable bond be more valuable than a straight bond? So the value of a puttable bond is equal to the value of an option-free bond plus the value of a put option. Why? Because a put option is valuable to a investor. Okay. The value of a put option is the value of a puttable bond minus the value of a option-free bond. In our example, the value of the puttable bond turns out to be 105.3. Does it make sense that this is more than 104, which was the straight bond? So this is greater than 104.6. The difference between these two numbers is the value of the put option. Okay. Sections 8 and 9, you can see how much content I have over here. Okay, these are, if you look at the at the learning objectives, I didn't even see a mention of these items. So I don't know if Shweta covers these or not. But I think the same concept that we have studied can be applied. A step up callable note would be maybe one where, you know, it's callable at a higher rate, or the coupon payment keeps going up. The core point is the procedure and the model that we've learned can be applied to all of these instruments. The binomial model is powerful because it could be applied in a lot of different scenarios. If somebody complains that with the binomial model we've just taken 1 year periods and we've just used 2 possible interest rates, okay, how would you counter that criticism? Because binomial model just assumes from a given interest rate there are only 2 interest rates you can go to. If somebody has a problem with that and says that you can have 3, 4, maybe an infinite number of interest rates, what's the counter to that argument? What you can do is you can keep reducing the time period. You can make the time period 1 day. That will be a problem for you, but is that a problem for a supercomputer? No, the concept is the same. You can just keep compressing the periods and make the computer work harder. But the larger point is, from an exam perspective, the model, that the structure that we've studied is what you need, and just go back and practice it. Okay.